unfortunately.
I had to edit you so much last time. Okay, so I guess just introduce yourself first of all.
Okay, I'm James Kimery. I'm Director of Wireless Software-Defined Radio and 5G at National Instruments.
So I think the best way to start with 5G is everybody has a different definition. Define it for me. What's your definition of it?
Well, 5G has many definitions, but I think in general it's the next generation of wireless. What is the next thing? It is the next thing that our wireless networks will migrate to. And so I think one of the things that I think makes 5G special is, and reason why a lot of people are talking about it, is because if you look at our current networks and the progression from 1G, 2G, 3G to 4G, I think, and then 4.5G, you can see that the technologies and the roadmap was fairly well defined. You know, from 1G is analog voice, 2G is digital voice, 3G was about some data. I won't say that it's mobile data, about some data. And then 4G was really about mobile broadband data. It's where actually mobile data was really useful. And that's what opened our eyes to, wow, what if our networks were more reliable? What if they were faster? What if they could handle more capacity? And then, the possibilities in terms of applications over and above what smart devices can offer, it's really astounding. So I think, when I think about 5G, that's a long setup there, but you think about 5G, it's that next step in our networks that kind of break away from kind of the traditional 1G, 2G. It's about addressing things like lower latency, better having responsive networks, or predictable response, more capacity, higher data rates, of course, but also power saving. I think once the technologies are available that address those, then that's 5G.
Nobody knows how we're getting there, but it's going to happen.
I'm convinced it's going to happen. Yeah, I think that I talked earlier about the 4 vectors of 5G. There's physical layer enhancements. There's wireless networks that includes densification. Massive MyMo, which we demonstrated with Samsung today or yesterday on the keynote floor, and then millimeter wave. So those are what we call at NI the 4 vectors of 5G, and we call them. There's a lot of different research that can be in those categories, but from an NI perspective, each one of those vectors uses a common set of tools and technologies like PXI or the USRP. And so it's if you're in that bin, that means we have a solution for you to begin prototyping.
So talk to me a little bit about the Samsung MyMo demonstration that you were talking about.
Yeah, so I mentioned that earlier. I classified it as massive MyMo, but really it's called FD MyMo, or full dimensional MyMo. And this was actually a 3GPP Release 12 study item that Samsung's been working on a while, and they contacted us about building, some prototypes, and we've worked collaboratively for about a year now, I believe. I think it's about a year, a little over a year. And what they want to do, they want to prototype LTE. They wanted to start with LTE having UE emulators connected to their eNode B with 32 to 64 antennas. And they wanted to assess the performance for the 3GPP study item. And, not surprising, it was very difficult to find off-the-shelf equipment that could do everything that they needed. They had some customization because FD MyMo is new, it's a new concept. And with the NI platform, they were able to do it, specifically the USRP Rio, LabVIEW Communications, and what I'd like to emphasize also is the LabVIEW Communications, these application frameworks. Samsung was actually, I guess we can talk about it now. Samsung was actually the lead user that helped us define the LTE application framework. And so at NI Week this year, we're also announcing an update to the LTE application framework, and a lot of that work was actually driven by Samsung.
Are there any other partnerships that you want to talk about?
Well, we also, at NI Week, we also showed our work with Nokia. demonstration of 10 gigabits a second using 73 gigahertz of spectrum, RF spectrum. That was that effort has been ongoing. Last year at NI Week we talked about 1 gigahertz in the E band, which is 71 to 76. This year we talked about 2 gigahertz, and so you can see the progress we've made in just 1 year. We've gone from 2.3 gigabits a second to 10 gigabits a second in really a very, very short time. And what's interesting about this is Samsung didn't have, or excuse me, Nokia didn't have to rewrite everything from scratch. They started from the initial prototype that we did last year, and then they were just able to extend it, and they had a high amount of reuse. You can't build a system like that unless you have a high amount of reuse, both in hardware and software, and so they're pretty happy. And in terms of the the 5G research vectors and who's winning, I think that both Samsung and Nokia are in pretty strong position because they're actually actively demonstrating these 5G technologies that may or may not appear in the standard, but well ahead of some of their competition, I believe.
And I mean, it seems like partnerships are essential to this. What's the importance of those partnerships?
Well, that's a great observation, and I think partnerships. Different companies have different expertises, and some companies are experts in millimeter wave or LTE, or you pick a technology. It's very difficult to be an expert in all aspects of the communication system. So partnering makes sense. And then where NI comes in is that NI is actually a natural partner. We don't really have a vested interest in what 5G technology wins. I mean, we want to work with everybody. We want to build the best set of tools and technologies for researchers to be able to take their ideas to prototypes faster. So I think partnerships are essential in the industry in general. Partnerships enable companies to leverage their collective strengths to build something better, and then NI in general is just, I think, a natural partner for doing this type of research.
What's the most exciting application that you either are demonstrating here or that you see in the future for 5G?
In terms of applications, I mean, I think right now for 5G, we are just kind of beginning to see what's possible with these data rates. But Andrea Goldsmith, Dr. Andrea Goldsmith today in the keynote talked about remote surgery, of actually having a surgeon located in Austin, that was her example, and the patient in Africa. And at first you start to think about that, right? You start to think about, well, how could that happen? Well, one is you think about the requirements on the network. That may not necessarily be a high data throughput application, but you definitely have to be responsive. And so the latency of the network has to be tactile response. If the surgeon's actually using virtual or remote type of robotic control, that response time has to be just like it is if they're using their hands. You have to have sensor data to be able to monitor the patient's vitals. But really, I mean, we're there now in terms of being able to get that data. And then you could actually make the experience even better than the surgeons today by having this augmented reality of overlaying the patient's visuals and what a surgeon would see with the vitals of the patient itself, and then any other data or parameters that can help guide them through the surgery. So, when Andrea brought that up today in the keynote, I think a lot of people were like, "Wow, I'm not so sure that's an exciting application." But if you think about it, what 5G can enable with more predictable response times, higher throughput data, and just the technology in terms of sensors and this augmented reality, it's possible. And it's even possible that experience could be better than a doctor actually being there.
Because it has all of the data from outside forces along with the human element of it.
Yeah. Exactly. And you can actually even think about if the surgeon were supposed to do something wrong, it could actually, or, you know, it could tell you before you did it, you know. So anyway, that was something that, you know, I think people in the audience were surprised and maybe a little shocked at. But when she went through the example and talked about it, it's something that could happen, and it may even be a good thing. And then, you know, she talked about some other examples like the autonomous car, which has been well publicized. You know, factory automation and using the cloud. Those are all technologies that are here. And, you know, we just need our networks to be a little bit better to really take advantage of them and have these applications really come to life and proliferate.
Anything else you want to say about 5G?
Oh, we could be here all day to talk about 5G.
Are you doing the panel later?
I am. I'm going to
okay.
moderate
Yeah, I'll
the
be
pattern.
there.
The panel.
But
And
yeah, what are you gonna? I mean, you got anything shocking that you're gonna talk about?
yeah, of course. I've been doing these panels for a while, and this year I'm going to do it all freeform. So what that means is I haven't prepped these guys at all. I did that on purpose, just so that you know, I wasn't lazy. I haven't prepped them, and I've given them some questions to think about, but some of the panels that I've seen, not to be critical, but I am going to be critical a little bit. You know, a lot of hear the same thing about 5G, but I want to dig a little deeper. And this is actually a really great panel with Dr. Goldsmith, Dr. Robert Heath, Dr. Amitabh Ghosh, and then Dr. Khan from Samsung. So we'll have kind of, you know, a group of researchers that we worked with, we know. But if anyone can handle that type of questions in that type of form, it's these guys.
You're throwing curveballs, huh?
Oh, all day, all day. And because, you know, I think people are tired of seeing the same type of panels. I went to a conference and there was like 4 panels on 5G, and you know, I think I heard the same thing 4 different times. So, so I'm going to try something a little bit different, and we'll see how it goes.
Good. I'm looking forward to it because I mean, I find myself